Welcome to December 11th LeetCode Challenge. Element appearing more than 25% in sorted array. Given an integer array sorted in non-decreasing order, there's exactly one integer in the array that occurs more than 25% of the time. Return that integer. So say we're given this sorted array of integer non-decreasing order, and we want to find the value that appears more, the integer value that appears more than 25% of the time. Just by glancing the inspection here, you have C number 6 here, which occurs more than 6, occurs 4 times, and the value of the array has 9 values, so 4 out of 9 would be more than a quarter of the array size. Here we have an array of the two values of 1, therefore 1 occurs more than 25% of the time. The length of the array is between 1 to 10 to the 4, and each value of index I is between 0 to 10 to the 5. Let's go about how do we go about solving this. So there's a couple ways you can go about solving this. You could use probably a count with a hash map. That would work. You could probably also use a binary search as well. But let's go with a different approach using checking for something that occurs at least 25% or a quarter of the time. So by taking the fact that say let's call our answer output, and if the answer makes up with 20% of the array, then what we could do is we could take a quarter of it. So that means if we have, say for instance, a length of 9, say the length of the array is 9, then we know that an element within the array must occur at least 3 times for it to be more than 25% or more for it to be more than a quarter of our array. So in general, the element the element that we're looking for must appear more than n over 4 times the size of the array in order to be considered. Because it is a sorted array, all elements are adjacent to each other and form a block within the array. So it's already sorted, so we know that 1 occurs before 2 occurs after 1, and it basically is non-decreasing order, so we know that each block has the same values in it. So with that kind of in mind, we can move from one block to another, and if it's more than a quarter of the array, then that's the one we're going to consider. So let's say the first index is block I is 1. As a consequence, above we could basically move the blocks until we find a greater than or equal value to the floor division of that specific index. So how do we go about doing that? So that's kind of the idea. Let's say we calculate the size of n over 4. We iterate from I to the length of the array, and then we look for our the largest block size that we can get. So we're going to do that. We'll just initialize an integer called size, and we're going to assign that right away to array.length. And we're going to also take the floor division of that divided by 4, because we want to find the size of something that's greater than 4. And then we iterate through the array length. So for I, integer I, equal to 0, where the increment would be I less than array.length minus the size, because we're all looking through the quarter of the length, and we increment our size I by 1. So when we iterate through each element index in the array of the length of the array minus the quarter size of the array, we're looking for if the array at the index I is equal to the array at index I plus the size of the array, So that means that it is bigger than a quarter of the size of the array. If so, we're going to return the array at that specific index, because we know that it's bigger than a quarter of the size of the array length. If not, what do we return? It doesn't give a return statement here, but there's exactly one integer that occurs more than once, but let's just return -1 or -1 as a out statement. And let's run this code. That looks good. Alright, so accepted. So time complexity wise, since we're removing a quarter of the array length, time complexity would be big O of n, since we only iterate through 3/4 of the indexes. So this performs that basically each iteration occurs at linear constant time, so therefore time complexity is big O of n. Space complexity, we aren't using any extra space for the integer size, so therefore it's linear, it's constant space as well. So kind of going over this intuitively again, since we know basically an element is an integer is ensured to be this is always going to have a value and it's sorted, and we know that the value must be occurring more than a quarter of the size of the array, so we could just use that to our advantage there and basically count or check the element of quarter ahead of the next block. And that's it. Have a great day, everyone.